Hello, I am Mark Wolf and I would like to demonstrate to you the latest version of my animatronic tail. The spline of the tail consists of a toy called a clix, which is a series of interlocking universal joints. I have joined these together utilising a piece of wire from a paper clip to which I have bent into a circlet at each end and threaded a bicycle cable through each of the circlets. At the end here I have secured the cable utilising a couple of screw points that I take from a terminal strip. This is so I could do final adjustments on the tail. As you can see, the unit is very flexible. The unit is powered by the motor controller system. This consists of a pair of servos, one here and one here, which drive a series of two pulleys which control the cable points going down through the spline. When one of the pulleys moves, it pulls the tail this way or this way, and so a variety of different positions can be generated. This is controlled by the controller, which is this small board here. I have secured this in utilising hot melt glue. The controller utilises a Pickaxe 08M processor, which is the smallest member of the Pickaxe range. The other components of the system is the battery pack, which consists of 6 1.2 volt cells given approximately 4,000 milliamps. This should power the tail and other equipment for about 4 hours or more. The control unit here consists of a small keypad with a 08M processor embedded underneath here. The way this works is that the keypad is connected together in a resistive network, so by pressing each key creates a different voltage that an A to D converter built into the 08M chip can read and work out which key is pressed. When the correct combination is pressed, the information is then sent up to the controller. The protocol that I use in here is part of a universal protocol that is used throughout the entire suit. Essentially, a line will go high, which causes the watching chip to trigger an interrupt, to which it is then goes down to an RS-232 routine awaiting incoming instructions. If I was using the follow me system, which enables the tail to wag naturally to a person's gait, I would be using these two items. These are actually flex sensors. As you can see, this is a flex sensor that when in this mode here will read approximately 9,000 ohms, and when flexed will cause the resistance to go up. I have one mounted at the back of each of these knee stockings, and when joined together in a resistive network will allow the system to work out if I am standing, kneeling with both knees bent at the same time, or flexing one knee next to the other. So let's see the system working. This is the tail going through a slow wag motion. This is a fast wag. Remember, there will be a furry covering over the tail that will mute some of the movements. Alternately, I can turn the tail off put the tail into a waiting state, or I could make the character look sad by tucking the tail between the legs. Or in the follow me mode, the tail can do this. With the follow me system, I can turn this on with the keypad, and the tail first will read what each of the sensors are as a calibration for when I'm standing up, and then will curl slightly to indicate that it is ready to receive instructions. As I lift one leg, and thus, if I'm walking, as soon as I stand still, or if I bend, both legs approximately the same, the system doesn't respond. However, any unequal bend will cause the tail to move. Thank you for watching my demonstration. In the future, I hope to be able to show you more parts of the animatronic project. Many thanks. And here is a list of people who I would like to thank for their help.